Hello, my algebra friends. We are coming down to the last couple things that we need to touch base on before we test the final unit test here. And one of them is graphing linear inequalities. So the first thing we have to do is make sure we rewrite this in slope-intercept form, step one. And so in example one here, you can see in order to get y by itself, I need to add 4x to both sides. And then there's no coefficient of y, so there's nothing to divide through by. And then it says graph the boundary line. So I put an equal sign in there, but really what's actually there is, that's out of habit, is a greater than sign. Y is greater than 4x minus 3. So when you have a greater than or a less than, you're going to use a dashed line. So this graphs just like it does when it's an equation. I would find -3 here on the y-intercept. I'm still going to go up 4 over 1, up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Then 1, 2, 3, 4 over 1 the other way. And instead of drawing a straight line, because this is greater than, but not less than, but not equal to, silly, I'm going to actually do a dashed line through there. Okay? This says that points that would make this equation true, or this inequality true, do not exist on that line. So let's take the point right here above the origin, +1, +1. This spot right here, 1, 1. That point is along this dashed line. So if I put 1 in for x, y is greater than 4 times 1 minus 3. So what we're saying is y is greater than 4 minus 3 is 1. Well, is 1 greater than 1? No, it's equal to it, but it's not greater than it. So that's why 1, 1 is not a solution. It's not a solution. So we use a dashed line to say we're not including the data on this line, but it's anything what? Well, how do we know which way we're going to graph? Well, we don't know yet. We have to test points. And what's the most obvious point on a coordinate plane? The most obvious point anywhere on the Cartesian plane? Well, it's 0, 0, right? The origin is the most obvious point. It's the most central, guaranteed point. So what we can do is put 0 in for x, and if whatever happens on the right side of the inequality makes a true statement with the left side of the inequality, then we know 0, 0 has to be included in our solution. It has to be included in the shading. So if 0, 0 makes a true statement, I'm going to shade everything to the left of this dotted line. And if 0, 0 makes a false statement, then I'm going to shade away from there. I'm going to shade everything to the right of this dashed line. So let's go back and try it. So we're going to say 0. Remember, the ordered pair we're using is 0, 0. This is our ordered pair, right? So I would say 0 is greater than or equal to 4 times 0 minus 3. Or 0 is greater than 4 times 0 is 0, minus 3 is -3. Is 0 greater than -3? Yes. So 0, 0 is a solution to this inequality. That means I have to shade the side that includes 0, 0. That's how you solve these. That's how you graph them. All right, let's try the next one. First step, put it into slope-intercept form. So I'm going to subtract x from both sides. So now I have 2y is less than 4 minus x. I'm going to divide the whole thing through by 2 to get 2y to be just y is less than 2 minus 1/2 x. Okay, so this is not a greater than, it's a less than, but it's still not equal to. So we want to start with the y-intercept of positive 2, and we're going to go up 1 to the left 2, because it's negative rate of change. Up 1 to the left 2, up 1 to the left 2, up 1 to the left 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And so what we're going to do is create a dashed line. And we're not really coloring in dots, because what we're doing is we're just creating like a boundary marker, right? We're not really drawing dots. And I kind of realized over here I had you draw dots, but at the same time, that's just to establish where the dashed line goes, because the solid dots usually means this is a solution, right? We don't want, it's not a solution because it's not equal to. Okay, so now how do I know which way to shade? Am I going to shade below that line or above that line? Well, again, I'm going to use the most notorious location on the coordinate plane, which is 0, 0. So when x is 0, y has got to be 0. And this needs to make a true statement. All right, so we'll put in this is x, and this is y. So y is less than 2, or we should say 0 is less than 2 minus 1/2 times, and what are we putting in for x? We're putting in 0. So we've now substituted 0, 0 in for our y and our x. Now if this makes a true statement, then 0, 0 gets shaded. If it makes a false statement, we do not shade the dotted side of the dotted line that includes 0, 0. So let's try it. 0 is less than, well, 0 times negative 1/2 is 0. So that gives me 2. Is 0 less than 2? Yes, true statement. Okay, so we have to shade the side that includes the 0, 0, because that is a possible solution. So what this is saying is that any point south of this dashed line is a solution for that inequality. So are you saying, Mrs. Evans, I can use the point 1, 1? Sure can. Can I use the point negative 3, positive 1? Sure can. How about the point negative 4, negative 4? Sure can. If you put those in for x and y, you will still get a true statement. So anything south of the dashed line will make a true statement. Okay? Let's try the next one. Now we have an equals to. So the first step is to get y by itself. We're going to subtract 6x from both sides. Now we're going to divide through by 3. Y is greater than or equal to negative 3 minus 2x. Or you could just say minus 2x minus 3. Computer proper, doesn't matter. Okay, now we want to graph like we would slope-intercept form. Start at negative 3 and then go up 2 to the left 2, because it's negative, up 2, sorry, to the left 1, silly Mrs. Evans. Up 2 left 1, up 2 left 1, up 2 left 1, up 2 left 1. Now, this time, 2 right 1, we're going to make a solid line. And the reason is because it's equals to, which means all these points that we just graphed are also possible solutions to the inequality. Okay. So I still need to figure out, though, which side of the solid line, to shade. That's a lot of S words. So if I put in, again, the 0, 0, the famous point, if it makes a true statement, we shade that direction. I'm anxious for this to not work, because so far it's worked both times. All right, 0 is greater than or equal to, well, negative 2 times 0 is 0, negative 3. Is 0 greater than or equal to negative 3? Yes, it is. So we're going to shade towards the 0, 0. Oops, I got a little overzealous with my shading here. Get rid of that one. Okay, so anything to the right of this line is a possible solution for this inequality. All right, one more. Okay, so let's check out this one. We need to distribute the 2 to both terms before we can isolate the variable. So 2 times negative 3x is negative 6x, and plus 2y is less than or equal to negative 8. So we add 6x to both sides. We have 2y is less than or equal to 6x minus 8. And then divide through by 2. And y is less than or equal to 3x minus 4. All right, so we're going to come down, and now we have to graph it. And so we start down here at negative 4. And we're going to go up 3 to the right 1. 1, 2, 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 3 to the left 1. Okay, so we have an equals 2 sign, so we're going to use a straight solid line. Okay. And we're going to use the famous 0, 0 to test our points. So put in the ordered pair 0 is less than or equal to 3 times 0 minus 4. And that leaves us with 0 is less than or equal to negative 4. And that's not true. So we're going to shade away from 0, 0. All right, now to test a point, let's try 1, 2, 3, 4, 5. 1, 2, 3. We'll try point 5, comma 3. Because that's now in the shaded area. Let's see if that works. So 3 is less than or equal to 3 times 5 minus 4. So 3 times 5 is 15. And 15 minus 4 is 11. So 3 is less than or equal to 11, and that is true. So we're guaranteed that our shading is in the correct direction. Okay, go back to your HyperDoc. Have fun.